Today I'll be showing you how to sketch this polynomial function. So for starters, the function is -2 x plus 3 whole squared x minus 5. There's a process I like to use specifically when I sketch polynomial functions. And the first step is to find the intercepts. Well, for this I used the property of 0 and I did f of 0 equals -2, 0 plus 3 whole squared, 0 minus 5. And through this I got -2 times 9 times -5, and ultimately I got f of 0 equals 90. And now we know that our point, when x equals 0, y equals 90. Well, that works. And then the second thing we have to do in my step process is to know the symmetry. We have to understand the symmetry of the graph if we're going to sketch it. Well, since f of -x equals -2, -x plus 3 squared, and then multiplied by -x minus 5 does not equal f of x here in this graph, then we know that this graph does not have symmetry. So we don't have to worry about finding the symmetry of the graph. The next step that I like to use, and a lot of people undermine this when they're trying to solve sketch polynomial functions, so I think it's one of the most important steps for finding the position of the graph, is end behavior. And we already have certain rules for end behavior. And for this case specifically, for my function here, we have a negative leading coefficient. A of n is less than 0. And we could think of it this way, and since we have a of n is less than 0, the description of this positioning will be a vertically reflected cubic, with the outputs decreasing as the inputs approach infinity, and the outputs increasing as the inputs approach negative infinity, which we have to keep in mind as we're going to start sketching. Our next step is to mark the points, which we already know. So when we started off by solving this, we figured out that when x equals 0, y equals 90. So we know that the turning point is going to be at 90, at y equals 90. Okay, that's a point we already have, and through the zero product property, you can calculate x plus 3 squared when it's f of 0. You can figure out that a point is going to be x equals -3, and the other point when x minus 5 equals 0 is going to be x equals 5. Therefore, another point is x equals 5. So our 2 points other than y equals 90 is -3, x equals -3, and 5, x equals 5. Something to keep in mind, and to also help you sketch the graph, is that the number of turning points does not exceed, and it cannot exceed, the degree of the polynomial. Meaning that here we have 3 degrees. The polynomial is to the 3rd degree. Therefore, we have to keep in mind that when we're sketching our graph, we can't have more than 3 turning points in our graph, because that's how many degrees we have. So it can't exceed that number. And now we're going to start graphing. For the sake of this graph and this function, I changed the y and x axis in order to be more suitable so you can see the true nature of this function. And here you can already tell by figuring out the end behavior in the beginning, we can know the flow and how the graph would move. And we already had 3 major points, 0, 90, and then -3, 0, and 5, 0. And so it was easy to graph. And a good way to check, as I said earlier, is to look at the turning points. Here in this graph, we have 2 turning points, which doesn't exceed 3 because this polynomial is to the 3rd degree. Therefore, we can verify that your drawing is correct.